Hello there. Welcome to Computer Programming Laboratory Lecture Series by Professor Nitin Pujari. Task number 2 is design and develop an algorithm to find the reverse of an integer number m and check whether it is a palindrome or not, and implement a C program for the developed algorithm that takes an integer number as input and output the reverse of the same with suitable messages. So they have given number is equal to 2014, reverse is 4102, not a palindrome. Okay, so we have to do bookkeeping before writing an algorithm, as I have told you. For example, suppose if we want to know what is a palindrome, a palindrome is one where if an entity either string or a number is equal to its reverse. Okay, for example, if I take string as say Nitin, reverse is also Nitin, hence it is a palindrome. Similarly, if I take a number 12321, reverse is also 12321, hence it is a palindrome. Okay, but the given problem now is we are not dealing with string palindromes, we are actually dealing with number palindromes. So if at all you are looking at number palindromes, if I have to reverse this, I should first be able to get a hand on each individual digits of this number, starting from the rightmost digit, then this digit, then this digit, this digit, this digit. We know all the numbers in this case by default are to the base 10. So 10 becomes a very important entity for us, right? Which means this is nothing but a cumulative sum to the base of 10, which is nothing but cumulative to the base of 10, which are nothing but powers of 10, which is 1 into 10 to the power of 0, 2 into 10 to the power of 1, 3 into 10 to the power of 2, 2 into 10 to the power of 3, 4 into 10 to the power of something like 5 into 10, 1 into 10 to the power of 4. So if you add up all of that, this you will get 1, 2, 3, 2, 1. Again, I will explain to you. This is nothing but you will have 1 into 10 to the power of 0, correct? 10 to the power of, maybe I will write like this, power of 10 comma 0, right? Plus you will have 2 into power of, that is my unit place. This is how we call it unit place, right? And then plus two into power of 10 square, tens place, okay, 100 place. So this is unit 10, 100. Then we have, this is our 1000 place. So to the 1000 place, what will I do? In this case, I have my number is 1, 2, and this is 3. So this I will multiply by 3. Okay. So what is my next number? My next number is again 2. So I will take this as 2 multiplied by 1000 place, which is 10 cube, right? Again plus I have this digit plus this into 10 to the power of 4, isn't it? So when I am starting from here, and if I add up all of this, right, I should be able to get this number. So this is my not 2, this is my 1 into So if you look at 1 into 10 to the power of 0, correct? 1 into 10 to the power of 0, 2 into 10 to the power of 1, 3 into 10 to the power of, this is how the numbers are actually looked at. But our job is now what? Is if I want to reverse the number, this should come to the 10 to the 4th place and this fellow should get to the 10 to the power of 0th place. So I will get the reverse of a number. So the logic looks complicated, but it is pretty simple. First thing is, I know that if at all I want to get this digit, I have to divide this number by 10 because the base is 10. Correct? So for that what I do is, if I have to extract the digit, my digit will always be number mod 10. Okay, in this case if I take 1, 2, 3, 2, 1 mod 10, which is the remainder, which is nothing but 1. Correct? But now my problem is, if I now want to get, if I want to get the second digit, I have to trim off this first digit. I have to trim off this first digit because I have already taken that digit out. So for that what I do, I have to take the number and divide the number by 10. So that's why I am trimming. So if I do that, I will get 1, 2, 3, 1, 2, in fact this should have been 1, 2, 3, correct? So I should get 1, 2, 3, 2, correct? 0.1, isn't it? Because it is an integer division, okay, 1, 2, 3, 2.1, I will get 1, 2, 3, 2, isn't it? So my new number will be 1, 2, 3, 2. So again, if I take this number and get the remainder of 1, 2, 3, 2, 1, 10, I will get 2. Right? So this I will repeat till my number is, I will repeat the above till my number remains greater than 0. Okay. But our problem now is, I need to get to the power of, I need to also form the reverse of a number. So my reverse of a number, what I will do is, I will start with 0. Correct? I will start with 0. So when I start my number with 0, correct, what I will do is, my reverse of a number is like this. So my new number, now I have to find the summation. Okay, so if I want to find the summation, so what will I do? I'll say my summation is equal to reverse into 10 plus digit. Okay, or I could as well say reverse equal to reverse into 10 plus digit. Let us see, let us trace it, what will happen here. Okay, so now one thing we have to look at is, how do I reverse the number? So what is my reverse logic? So what I do is, for every step in the above block, we will calculate reverse. Which initially is 0, which means every time my reverse will be my previous reverse multiplied by 10 plus the digit that I am extracting. Now how does this work? For example, if I have 1, 2, 3, 2, 1, right, and I take mod of 10, if my, right, so my digit will be equal to 1. Okay, so my reverse will be equal to, initially my reverse is 0, so it is 0 into 10 plus digit. Correct? So my reverse will now be 1. Hence my reverse will now be 1. Okay, Similarly, since I am in the second step, what I do is I have this number, correct, and after that what I do is I will do my num will be equal to 12321 divided by 10. Okay, so I get 1232 mod 10, which is nothing but 2. So since my previous reverse was 1, so my this will be 1. So my new digit will be, hence it will be 2. Okay, so here in this case it was 1. So hence now my answer will be 12. Reverse will be 12 as of now. So if you see, we are already getting this. So we are actually starting from here. We actually got the reverse up to this digit. So again, my number, what I will do is I will take this number and divide this 1232, my new number, by 10. Okay. So in this case, if my number was initialized to 12321, so I will just do num equal to num divided by 10, so that we get the value. Okay, so that is my num. So next time what I do is I get 123 mod 10, which is nothing but, now in this case my digit will be now what? It will be 3. Correct? So my digit will be 3. My reverse earlier was 12. Correct? So it will be 12 plus 3. Correct? Hence my reverse will be 123. You see, 123, I am already getting this. Correct? So let me just again keep on dividing the number now. So my next number will be 12 mod 10. So my digit will be 2. My reverse earlier was 123. That I will multiply by 10. So this I will make it as 2. So my it will be 1232. Okay, so I am already getting 1232. Okay. And now if I take this entire thing again, divide my 12 by 10, what I get is 1. So my digit will be 1. So my reverse will be 1230 plus 10 into, plus the digit, which is nothing but 1. So hence my reverse will now be 12321. So again my number will be 1 divided by 10, which is nothing but 0. So my everything stops here. So then I would have saved the number in original. You have to save the number in original for comparison. So my original will be 12321. So I will compare my reverse with original. So if my original is equal to reverse, then it is a palindrome. Hence not. Okay, so this is what we have done, something called the bookkeeping, right, to get the logic of the program. Now writing algorithm becomes simple. I hope you have understood this logic. If not, rewind the video and start all over again. Okay, so now we will start with the algorithm. So what does the algorithm now do? In my step 1, I will accept n, which is the number. In my step 2, I will store my number into original. Correct. In step 3, I will initialize my reverse is equal to 0. In step 4, I will do while n remains greater than 0. So I can as well say n greater than 0. Okay, do steps 4 through, will come to those steps. So my step 5 will be, my digit will be equal to n mod 10. My step 6 will be equal to reverse into 10 plus digit. My step 7 will be num n is equal to n divided by 10. Okay, so my steps 4 through 7 will be repeated till my value of n remains greater than 0. Okay, now my step 8 will be, if my original is equal to reverse, then print original is a palindrome. I have stored in the original because I am dividing n, so I may lose the value of n. Else print original is not a palindrome. So this becomes my algorithm, and step 10 or step 9 I will stop. Okay, so I can also have a step, I can as well say start, or I can also have a step start, right? So this is what is my simple logic of this program. So if you look at this, the logic is simpler than the paragraph of the program, right? But we were able to figure out because we did a lot of bookkeeping. Okay, hope you understood this logic. Okay, we'll try and write the C program of this. So what you have to do is, you please go back. If you have not understood, just go back, rewind it, and slowly you will be able to figure it out. So let me write the program. Okay, so my program will now be, so what do I do with my program? I just take the program to check whether a given number is palindrome. Okay, so first, as usual, hash include stdio.h int main, open bracket, close bracket, do this, close it. Now I have to declare my int n. This is for accepting n. Int original this is for storing n. Initial value of n. See, in the previous video also we saw I am giving this double backslash, forward slashes. These are nothing but comments, so it will be ignored by the compiler. So I need reverse, I need digit. Okay, so we have all of this. Now since they are all global variables, I don't have to initialize because they will be automatically initialized to 0. So now what I'll do, printf /n enter the value of n, scanf %d and of n. So my original will be equal to n. So I'll just also echo this, the value of n so we will also display the value of the original. Okay, so the value of the original is this. We'll save this, compile the code. We'll do the OP. Okay, so we'll enter the value of n. We'll say 1, 2, 3, 2, 1. So the value of n is 1, 2, 3, 2, 1. So we are able to accept the input properly. Now let us look at the logic. So our logic was pretty simple. If you remember the algorithm that we developed, while n remains greater than 0, digit is equal to n mod 10, because mod, instead of mod in English, I have replaced it by the mod operator. My reverse is equal to reverse into 10 plus digit. Okay, then my n is equal to n divided by 10. If you really want to trace our algorithm that we wrote, we will just display the value of reverse at every stage. Okay, we will display the value of n and the value of reverse, both we will display, so that you will know how the value of n is getting diminished, right? This is only for trace. This will not be a part of code later. So the value of reverse is, we are just printing the intermediate results just to make our understanding better. Okay, so let us save this code, compile this and do the OP. So now let us give 123. Now if you see, the value of is 123 in the beginning, the value of n is 123 because we have displayed, this is for the first statement. The reverse is 3 for the first time, value has become 12, then the reverse is 32 and the value of n is 1, the value of reverse is 321. So 321 is not equal to 123, right? So let me again do it once again. So let me take 1, 2, 3 to 1, our example. See, the value of n is 1, 2, 3 to 1, reverse is 1, 12, 32, 12, 123, right? The reverse is 120, the reverse is 123 from the original day, then 1, 2, 3 to 1, 2, 3 to 1. Now this is equal to the number, that's why it's a palindrome. Okay, so let us also give this input that was given by the VTU 4102 2104. Okay, so 4102 becomes 2014. Okay, so or 2014 to be precise, to give you 4102, right? So we are already there, and which is not a palindrome. So now what we will do is, we will just take this fellow out and then we'll put a condition. The condition is, if we have to now compare with the original, because the value of n has become 0. If the original is equal to reverse, then %d is a palindrome. Or we could do this, the value of reverse also we will put, the value of n also we will put, just to make the display better. I will take this fellow above, and then once I do that, so my value of n is I'll put the original, I don't put n because I told you the value of n has become 0. I'll make this as original. So depending on the value, user can also compare. Printf %d is a palindrome. Okay, this I will put it outside so that before any results are displayed, we would like to take that. Okay. Then I don't need this block. This is a palindrome, which is nothing but original else it is a palindrome. It is not a palindrome. Okay, we will save this code, recompile it and check our output. Okay, we have given outside the scope. This is our original. Okay, save it. We get this typographic errors. You will also get the typo errors, so don't worry about it. So I give 1 2 3 2 1. It says it is a palindrome. Then I say 1 2 3 4 5 1 4 5. It is not a palindrome. Then I give OP 0 is a palindrome, 1 is a palindrome. I told you in the beginning single digits are all palindromes. And then if I give 10, 10 is not a palindrome. Okay, but if I take 11, 11 is a palindrome. So our program has now worked on all the conditions and we have gone everywhere in terms of its code coverage. So this is our final program. Hope you understood it. Please go through the video once again to master this particular program. See you in the next videos. Thank you very much.